Now we have discussed the diffraction numerical. Question number 1. Light of wavelength 5500 angstrom is incident normally on a slit of width 22 into 10 to the power minus 5 centimeter. Calculate the angular position of the secondary minima. As you know, second minima means n is equal to 2, and for the single slit diffraction the angular position is given as sin theta is equal to 2 lambda by a. So theta is equal to sin inverse 2 lambda by a. After putting the value we calculate this. Now the second question is, a diffraction grating used at normal incidence gives a yellow line lambda 6000 angstrom in a certain spectral order superimposed on a blue line lambda 4800 angstrom of the next higher order. If the angle of diffraction is sin inverse 3 by 4, calculate the grating element. As you know, grating element is given as a plus b or e plus d, and the direction of principal maxima is given as a plus b sin theta is equal to n lambda 1 for the first, and the next one is given as a plus b sin theta is equal to n plus 1 lambda 2. After solving these two equations, we have calculate here n, which is comes n is equal to lambda 2 upon lambda 1 minus lambda 2. After putting the value of n in equation 1 or in equation 1, we have simply calculate a plus b sin theta. From here, after putting all the values, we have obtained this. Now question number 3. Light of wavelength 5000 angstrom is incident normally on a slit. The central maxima falls out 30 degree on both sides at the direction of incident light. Calculate the slit width. As you know, for a single slit, the direction of minima is given as a sin theta is equal to n lambda. Here a is slit width, theta is diffraction angle, diffracted angle, n number of order, and lambda is incident wavelength. Simply we just calculate sin theta is equal to lambda upon a, and here we calculate a, which is lambda upon sin theta. Everything is given in the manner, just simply put on this. Question number 4. Calculate the angle at which the first dark band and the next bright band are formed in the Fraunhofer diffraction pattern of slit 0.3 mm wide lambda this. As we calculate earlier, single slit, the direction of minima is given as a sin theta is equal to n lambda. Here we have to calculate theta. Theta is comes as sin inverse this, and we calculate theta from 0.112 degree. The angle of diffraction theta corresponding to the first bright band on either side of the central maxima is given as a sin theta is equal to 3 lambda by 2. Here we further calculate this, sin theta is equal to 1.5 lambda by a. Since lambda by here we already calculate 0.112, just put this and calculate theta. Now question number 5. A single slit is illuminated by light composed of two wavelengths lambda 1 and lambda 2. One observed that due to Fraunhofer, the first minima obtained for lambda 1 coincide with the second diffraction minima of lambda 2. What is the relation between lambda 1 and lambda 2? As we have already used this formula for single slit, the direction of minima is given as a sin theta is equal to n lambda, where n barabar 0.23. For lambda 1, the direction of first minima is a sin theta 1 is equal to lambda 1 for first, and second one a sin theta 2 is equal to 2 lambda 2. But we have given lambda 1 is equal to 2 lambda 2, and lambda 2 is equal to lambda 1 by 2. This is the desired relation. Question number 6. For a plane transmission grating, the angle of diffraction for the second order principal maxima for lambda 5 into 10 to the power minus 5 centimeter is 30 degree. Calculate the number of lines in 1 centimeter of the grating surface. Here, as we learned from the n is equal to 2, n is equal to 2, theta is equal to 30, and lambda is equal to this. From grating direction of maxima equation, a plus b sin theta is equal to n lambda. A plus b is equal to n lambda by sin theta. Number of lines in 1 centimeter, 1 upon a plus b. So sin theta is equal to n lambda. So we have calculate 1 upon a plus b is equal to sin 30 upon 2 into 5 minus 5 is equal to 5000. This is how we calculate the number of lines. Question number 7. Calculate the angle between the central image of a lamp filament and its first diffracted image produced by a fabric with 160 thread per centimeter. As you know, thread is work as a diffraction grating, so we have calculated here grating element, which simply just calculate. It is given in 1 centimeter, so we have calculated a plus b is equal to 1 upon 160 for grating. A plus for grating equation, a plus b sin theta is equal to n lambda. So here we calculate sin theta is equal to n lambda upon a plus b. Putting all the values and we calculate theta simply here. Question number 8. Light of wavelength 5 into 10 minus 5 centimeter incident normally on a plane transmission grating of width 3 centimeter and 1500 lines. Find the angle of diffraction in first order. Here we have first to calculate grating element, which is width of grating upon total number of lines on the grating. Simply in the question, width is 3 and the total number of lines 15,000 for here. Now applying the grating equation, a plus b sin theta is equal to n lambda and sin theta is equal to n lambda upon a plus b. Putting all the value, we have calculated theta here. Now question number 9. A diffraction grating used at normal incidence gives a green light 5400 angstrom in a certain order and superimposed on the violet line 4050 angstrom of the next higher order. If the angle of diffraction is 30 degree, calculate the value of n. Also found how many lines per centimeter are there in the grating. Here two wavelengths are given. First of all, we have used grating equation a plus b sin theta is equal to n lambda. Let nth order maximum lambda 1 coincide with n plus 1 order maximum lambda 2. Then we have a plus b sin theta is equal to n lambda 1 is equal to for the nth order n plus 1 lambda 2. After solving, n lambda 1 is equal to n plus 1 lambda 2. N barabar after solving lambda 2 upon lambda 1 minus 2, as we have done in the previous question. We have a plus b sin theta, just putting n in equation 1 or either in equation 2, we have lambda 2 lambda 1 lambda 1 minus lambda 2. Here solve for sin theta and putting all the values, here we calculate n. Now first of all we have to solve n. Now putting all the values in this equation, and now we have solved grating element, which is comes whatever values comes, just to calculate number of lines we have just divide 1 by a plus b and we calculate number of lines. Question number 10. In a grating, which spectral line in fourth order will overlap with third order line 5461? As you seen from the equation, for grating equation a plus b sin theta is equal to n lambda, let nth order maximum lambda 1 coincide with n plus 1 order maximum of lambda 2. Then we have n plus 1 sin theta is equal to n lambda 1 is equal to n plus 1 lambda 2. Here just calculate lambda 2 n lambda 1 upon n plus 1. Here n is equal to 3 and we calculate just this. Question number 11. A plane transmission grating has 40,000 line. Determine its resolving power in the second order for wavelength of 5000 angstrom. As your resolving power is given as lambda upon d lambda is equal to n, where n is order and n is number of lines. Just simply put these two values in the equation and we got this. Question number 12. Find the minimum number of lines in a plane diffraction grating required to just resolve the second sodium doublet 5890 and 5896 angstrom in the first order and second order. Now here n is equal to 1 and lambda is equal to lambda 1 plus lambda 2 by 2. Just solve here and we calculate now d lambda. D lambda is equal to 5896 minus 5890 is equal to 6. So resolving power, as we have calculated previously, lambda upon d lambda is equal to n. Here we have just calculate n here. After taking n from equation of resolving power, we have this. Now putting this into this, we have n is equal to 982. This is for n is equal to 1. Now simply just put n is equal to 2 in the equation and it is come out this. Question number 13. Can D1 and D2 line of sodium light by resolving power lambda D1 this and lambda D2 this lambda D1 5890 angstrom and lambda D2 5896 angstrom in second order. Number of line in grating of 2 cm wide is equal to 4500. As we know, n is equal to 2, lambda is equal to lambda 1 plus lambda 2 by 2 and d lambda same as the previous question. So from this we have calculated lambda upon d lambda upon n is equal to 2 is equal to 5893 upon 1 into 6, and from here we have calculated n is equal to 5893 upon 12 is equal to 491. So we have see here given n is equal to 4500 greater than required value, hence lines can be resolved in the second order. This is all from the diffraction numericals. This is all from the diffraction numerical. So you have prepared well, and if you have any problem then contact to any physics faculties.